Hey guys, it's Gladys. Different background because we are in a different location. Again, Pennsylvania, but that doesn't stop the grind. So today on Work With Me, we have to redo the grading for a project that doesn't seem to be graded correctly. When another engineer was working on it, they were confused about the sloping and grading, so I thought it was best to just regrade it myself and have you guys walk it through with me. So let's engineer something. So to start off, here is the product and design. We added later on, after the design was pretty much completed, they let us know that they wanted to add two additional parking spaces here. There's already one parking space to the south here that has a cover, and also we suggested that they added some landscaping buffers around the parking area as well. So here we're starting off by looking at what this elevation is. And I don't know if this quite makes sense. I think we are going to eventually lower that elevation. So here we're measuring so we're going to create a wall. We're starting off right now just seeing if the wall is the best bet for this design. Also increase, because we only really need half a foot. We ended up making this permeable pavement a little bit slightly bigger because we only need a half a foot of edging between the landscaped area on this side and the permeable pavement. So we only need a half a foot. So we ended up with a curve. So we ended up just making it a little bit bigger. I think the person before probably made it a foot big. And I think that was most likely because this is a site where we are it's 2 buildings or 2 units, and they most likely thought that this project needed a green area ratio, but green area ratio is only required when the site is over 3 units or the cost of construction exceeds 100% of the tax assessed value of the building. And it's not doing that. It's not either of those for this project. Here, the slope is actually isn't showing much. After looking at what this is and what the bottom number is, and also we are going to add a wall along this, or a small curve along this area, we are then saying, based off that slope that we are saying that's going to be, and we're making it that slope based off of, let's go back, us making this number 4.5. So this back number, the bottom of a curve, is here. This location right here is 45.25, and this right here is 39.95. We find the slope between those two areas, and this is the slope coming down all the way to this point, and that's where we're going to say that this slope this area is. The reason that's going to be is if the existing elevation is 45.75, we're just lowering it slightly so that we can obtain this slope, which we need it to be less than 5%. But that's why we're lowering it by that amount. Now we're just adding 1 foot contours. So these circles will represent the 1 foot contours. And a lot of this we'll be playing around with, just not guessing, but using the site or the different boundaries of the site to really gain more access and information. So yes, this was over 2 hours long of me doing this design, but it was a lot of back and forth so that we can ultimately get to the design that is preferred for this project. So here it starts at 39.55, and that's 40, 50, 40, 41, 42, 43, 44. And now we have to really think about what's going to go. Now we have established what's going on the left side. Now we got to go onto the bottom and then right. Then we're going to work our way in from there. Here, a lot of these things, they don't have to stay the same. So once you do say this is 45, this is this number, you may go back and change it afterwards, after you look at something that happens in this top or area or somewhere else. You may see something and you realize, I need to change this design slightly. I need to make adjustments, which we will be making during this design. So here for now, we have this as 45. Let's see how long that lasts. The reason why we came up to 45, we have a curve here at the back of the site, having this 46, and then it connects to the 45. And we are also assuming that these contours or these elevations are correct. Also, I don't sound like that, but that was done right there. Just having a spot elevation on an existing contour. I prefer you just have the existing contour on, or existing spot elevation on it. It gets confusing if it's not done that way. So the wall comes to here that we're having, wall in the back, and a wall on this side. And they're all just small curves, just so that the slope of the site makes sense. It's not too steep going one way, and water is going the direction that we need it to. Because for example, this wall wasn't here, it would most likely be that this 44 contour, it would really be this area in the northeast would be really steep. Again, we're playing with the slopes. We found this one, it's probably best at 44. And again, we're gonna be changing our minds a lot during this entire process. The top of curve is 45 here. We're lowering this. This can't be 45 up here. And the reason why this can't be 45 because this 44 is here. So that would make this extremely steep. So this is 45 up there. So I'll pause it. So if this is 45 up here, we have 45 down here, and this 44, 45 over here. That's why we have a wall or a curb, really. And a lot of it is like arithmetic, repetitive. That's the biggest thing about grading. It's not quick. It's like repetitive, and you just get good at it eventually. I think grading is one of the most hard. It's like the hardest because you have to think a lot and you have to go back a lot. When you're doing a lot of other designs like profile, it's not as much going back and forth. So we're going to trust that this right here is correct. We're going to use it from this point to this point. We've established at this point, okay, this is 44. We stopped here for some reason. Let's see, I think we just can stop here. I think we just let it here. Left it here, so this is 44.5 at this point. So 44 has to end somewhere in here, actually, or that doesn't make sense. This is 44.0 here, and this is 44.3, and this is 44.35. This needs to go downwards. This is hot. Yeah, this is incorrect. See, this is the reason I was saying that this elevations are slightly incorrect. So we see here, 44 should be ending right there. And this is actually incorrect. If this is a 44.3% slope, that doesn't make sense. We'll have to adjust this. And I believe the issue here is that it's a typo. It should be 43.35. So when we ended up doing the math, we saw that that's actually supposed to be 43.35. So that's another thing. When you're doing your work, check that you're entering in the correct numbers, because then it would snowball. If you put this as a 44.35, it snowballs everywhere else on this set of design. See? 43.35. So, and this is important, just double check. That's a foot difference right there. So that's 44.35, which is 1 foot higher than it should be designed at. That's a pretty big mistake, but if this is a smaller project, but if it was a bigger project, that would be a big cause of concern. So now we're grading the center area, and we're trying to make it like not too steep. There's no ADA spaces here in these parking spaces, so it's pretty standard. So as long as they're less than 5%, we should be fine. And here, this area, we maintained a 4.33% slope, and with that, we have like 0.17. We're gonna reduce this by 0.17. This is about, I probably did mental math on this one. No, I didn't. Thank goodness. So it's still 17. And it was bad. Increasing the numbers. So like here, now we're going here. We're going from 44.3 to this number. And we got to figure out what it is, what is best for that number. And we do end up changing this. I flipped it at first and I was like, wait, we should have the water come this way. But then I thought about it. Water will be trapped and going towards the building. We want water to come this way and just be absorbed into the permeable pavement as much as possible. So again, it could be the max slope that we can have here is 5%. It's because we want a ADA compliant, accessible walkway. So we want it to be less than 5%. So we have a 3.5% up to this point, and we're just increasing it so that it also makes sense. So here we have this point here at 44, and it comes up to here. We want it to be relatively flat. So here we have this 45, and we have the 46 over there, which I think I skipped past that part. It just needs to make sense. Eventually, we will be some more further adjustments once we do some more grading in this back area. So, but we will get there. Okay, so we're just moving the 42 contour to down here to this location, and then we're going to be connecting it to a location that's up here, because this area right here is 42, but there's no 40. It's not possible 42 to also be here. So what we're going to do is also measure a line from down here to best get a good points of reference. So this point here, I used to like to draw circles as lines. See here, we drew a 46 line, and the reason being So after looking at it, top of curve, I need to adjust that, as the back of curve is no longer that. I need to adjust that later on. So the will be 46, and it'll be touching this point right here, which is also 46. 45 for now, and then 44 for now. Okay, let's go back a little bit here. So now we're going to be doing the parking spot elevations. We'll just add a spot elevation here, like I always do. They're the same exact numbers, so that's how I know that these are just like spot elevations. We have that saying, and then we're going to be saying that we're using, let's go back. I want to see, how do we decipher that is 3.95? Okay, we have. So using the fact that we have this contour that we've already established is 45. So we're using that to determine or to establish what this slope will be. So as you can see, we have this 45, we have this elevation is 44.35 that she established from this point going here, coming down here. As you can see, we did math here. So we do 45 minus 44.35 divided by whatever that is, divided by, and we get 3.95. So that's why that elevation was 3.95. For that elevation was slope, sorry. And from there, we're going to decide or determine what these spot elevations. I like to put spot elevations on every corner of the project, of the buildings, as many as possible. This could really paint a good narrative of what's going on. Another thing about spot elevations is that they tend to be more accurate than the contours. Contours are usually a guesstimation based off of the spot elevations. So spot elevations are going to be more accurate any design you do. So here, this is 0.75. So what we did was this distance from this point to this point is 18.99. We multiply that by the slope, and that's when we get this, the rise from 44.35 to this point by 0.75 if the slope is 3.95 over a distance of 18.99 feet. So let me just draw that. So we have 18.99 feet. Side is 44.35. We have a slope of 3.95. This distance from this point is 0.75. We have this at 44.35. So now, what is this new number? This new number is going to be 44. This new number right here is 44.35 plus 0.75, which is 45.1. How easy that is? All you're doing is determining this distance and what that new number is. Because if this was 0, this would just be 0.75. And then we're going to do the same thing over again on the bottom side. And we have to do the math because we already know it's 0.75. So we're just going to add 0.75 to this number. So that's 45.8. Let's move that a little bit off of the existing. So there's no overlap texting. That's 45, and that's based off of the elevations and numbers that we have. Again, we just made sure that those numbers made sense based off of the elevations and all the slopes that we've done. So all the slopes adding up, this site is coming together very well. Let's keep moving around. Oh, and also here, we skipped this part. I think I missed it, but we ended up making this area go this way. I think previously I had flipped it around because I was like, okay, the water goes this way, so it's not going into the neighbor's yard. It's a 1% slope. It's like not deep enough. It's not steep. So water's going this way slowly, permeable pavement surface where it's going to be absorbed in. And also it's a little bit further from the neighbor's house. If we go this way, we're going straight into our home. So this way allows it to go straight into the home. This way is going this way, but it's also going outside of the house. So we want it to go leave the site. This area is a vehicle accessible area, and this area is also a vehicle accessible area. This water needs to go into the permeable pavement to be treated. These vehicle accessible areas need to be treated within this area. So the DOE requirement requires that 50% of these areas be treated. 50% of vehicle accessible areas are required to be treated. Let's move around. So we see that here, 1,000. So that's still good enough. We still maintain the same slope. So this is 45.85, which still allows for this to be true. These are slopes of the roof. should also change that into something else because it can be quite confusing if it's the bottom or it's the roof. So these are actually the slopes of the roof from what the architect has provided to us. Here I'm adding landscaping buffers on the front as well. At first they were supposed to do a dog park, but I think the owner decided against that because this is our rentals. Now these are just garden in the back for the grill. And here she's having an area to walk up the stair and possibly have a deck at the top of that roof carports are. I'm also adjusting. I think the demo layers are on, so that's why you see a lot of this mishmash. I'm also going to be fixing these elevations as well. As you can see, it says 43, it says 40. I don't know where the top of 43 is coming from. I don't see, actually, yeah, it's 43.5. I'm assuming that this red right here is a wall. So as a result, this why they put top of wall here is 45. But it should be a little bit higher because you see right here is 45.58, 43.58. So it seems as if this entire area, let me adjust this slightly. So this stair right here, this exact location is 42.86, and this is based off of the existing topo that's around, and also the stairs that's right there. It's the bottom of the stair is at the bottom of this area. The stair ends at 42.68. So when this person enters, there's no longer any stairs that like protrude out. It now stops at that base of the bottom of the stair. So now we're just going to go and look at the stormwater management plans real quick and make some small adjustments. So in the stormwater management plan, I'm going to put the plan set together. I was just making small adjustments to the drainage divide and drainage area. So we were expecting, because of the roof drains and because of the sump pump, that approximately everything that's in the blue area will be draining into the permeable pavement, because we're going to have sump pumps that's going to outfall onto the permeable pavement. We're going to have the downspouts that's going to outfall into the permeable pavement, and natural grading outfalling into the permeable pavement. Keep moving around. Also, we have to adjust these numbers as we see fit. So that now the entire site was a drainage area, and now we're reducing it to make modifications to what the natural grading of the site is, or the proposed grading of the site is. So with this new blue line, we have only 6,404, and we're going to also update the calculations for this project. A little further small modifications here, because I don't believe that this area can drain technically into that permeable pavement, but it's more likely that it's going to drain forward. Just makes more sense. And then going this way, actually, it most likely will, because the natural grading of the area goes towards the left. Now we're just gonna go back into the site, the X reference site, just so we can figure out what's going on there, and also we can update these numbers here. So we did modify the permeable pavement slightly. The compact area of this site has changed, because you see I have 1444. I think we already modified that, but we're just going to double check all the numbers. I think I asked Lee when I did the numbers for the compact area, I forgot to input this compact area. So we are being very generous with our numbers, which is exciting. So being generous, underdoing the compact area is always better than overdoing the compact area, because the impervious area accounts for much more, or requires much more treatment. Here we're just making sure we're counting it. What I like to do is draw polylines and a plot. Here I can click this button. I come to this location, I click this button for any type of like a new line that I'm creating. And for this one, I made this a VAA, which is a vehicle accessible line, and I made it a no plot layer. It's so I can measure that area so I can put it into my calculations. And also, while I was doing that, I went ahead and I also added the compact area that's going to be here, which is going to be sodded. So this is different. This is a different type of landscape. So this is going to be sodded. I'm going to show that. And we have to move the sod off of the shrubbery around. That's done. The demo layers are still on, or I think that these need to be demoed as well. I'll have Patrick do that. And listen, I'm excited. Now I'm just looking at emails, making sure that we have all those, that we have everything we need. Let's move around a little bit. And also double checking the infiltration rate. We have iteration of 0.8 before we were showing 0.2. So good thing we double checked that and we updated that infiltration rate from the geotech report. Always check your geotech report, read your geotech report, because you'll find good information in there about the site and surprising information about you can make your design. Also adjusting slightly some of the keynotes, but I'll leave the rest to Patrick to finish it up so that he can make the plan set together and we can go over that plan set as soon as they are done putting it together and before we submit. Okay, we got through this design. We went over the grading, my general thought process, and a few best practices at the end. And we did a little bit of stormwater management. Yay! Like, subscribe. Thanks for tuning in and see you next time, and stay tuned. I got more coming for you. Bye.